Oh man, another one that's not shipped exactly right. No padding whatsoever, and already seeing that back coming off. That's not a good sign. This one I think took some damage, so let's get it out of the box. Oh yeah, I can tell already it took damage, huh? That's not good. So let's go and get it out of the box and see exactly what the damage is. I'm pretty sure it got the bent knobs because you can see this is banged into there and stuff. This is not how you ship equipment. I don't know what's wrong with people. So do have it completely out of the box, and you can see how the case starts sliding off, so hopefully there ain't no damage on the inside. And this rear was pretty much, you can see there, it's just kind of hanging about. So there you go. And the reason for that is because there's no screws or no feet that go into this that holds this to this. So I'm hoping this actually survived on the inside and didn't cause no damage to any of the components inside. We'll have to slide the case completely off to see. But here's the front of it pretty much. And let me go ahead and just turn this around so that we can get a better view. And yep, all the knobs seem good. Nothing seems cracked or broken or anything like that, so that's a good thing. I was expecting to at least have a couple knobs broken and stuff the way it was shipped, because this was banged into the edge of the car, but there was no padding on it whatsoever. Not how you ship a scope, but it looks like it's in relatively good nick despite how it was shipped. I'm going to contact the seller, see if he has the rear feet, because I have a suspicion he took them off to try to get it to fit into the box. Man, I'm hoping there's no parts missing and stuff in this thing, because I would like to get this thing going. It's actually one of my all-time favorite oscilloscopes, and this is actually the one I learned on when I started electronics and stuff like that. I actually was given one of these for free, and was actually one of my first scopes, so I definitely want to get this thing going. But before I go ahead and do repair videos of it, I do gotta get a GoPro swivel mount that comes down like other tech reviewers do, and I kind of want to do a real-time troubleshooting and repair of this thing instead of holding the camera and having to shoot it in parts. I kind of want to step it up a little bit, so I'm going to mount a GoPro here at an angle, and then it can swivel it the way I want to and actually do the troubleshooting and stuff like that, because this is going to probably require extensive repair, especially seeing the condition it's in. But this will be an upcoming video. I'm going to go and slide the case off, and I'll show you if there's any damage or not in the inside. So here's what the Tektronix 465 2-channel oscilloscope looks like in the inside. And thankfully, there's no components rolling around in the case, or boards damaged or anything like that, or any of the shafts broken and stuff. So this looks like it's going to be actually repairable. So that's a good thing. Of course, I don't know what exactly the issues are. It was so broken as is. And I believe it is broken as is, because I actually had one of these. And this was one of the first scopes I actually learned on. And I dealt with my fair share of problems with this oscilloscope. So thankfully, I'm kind of familiar where everything is and how to service it and stuff. But one of the things I kind of dread is having to do a full calibration on this thing, because the calibration procedure, 40 pages long, and you need obviously mainframe scope, 3 of the Tektronix signal generator, which shockingly I actually have. But there is one piece of gear that I do need to obtain or borrow or something. I'll figure it out or find a workaround it if I do have to go to that. First thing we got to do is see exactly what the problem is, and this is going to be a future repair video, probably not soon, because I do got to get a GoPro arm attached to here, so that way I can swivel the GoPro and actually do a live troubleshooting and repair and stuff like that, instead of shooting the videos and parts and editing it, because I know a lot of people want to see it, especially with something like this, so it's something that I do want to do. Thankfully, I don't see any burnt up tantalum capacitors, because normally when they go bad, they go ahead and have a tendency of catching fire and turning black. They look like they're all intact, but they're probably going to need to be replaced. Of course, I do believe this thing's probably going to have power supply issues and stuff like that, so that's probably one of the first areas I'm going to have to check. because that's typically what causes tantalum capacitors to go bad, is when there's excessive ripple on the power supply, and tantalum capacitors don't like, ripple pretty much, so that's what causes them to burn up. The other thing too is I'm probably just going to go ahead and replace most of them because they do tend to fail short when they do fail. And that's not something I want. I want to make the scope kind of reliable if I am actually going to use it. Not sure yet. Well, let's go ahead here, the other part of it, and let's just see if we can do this without slamming it down here real quick. That we're going to have to service definitely is going to be this attenuator right here. And you can see how it works. There's these leaf springs. When it hits those notch, it pushes those switches either on or off. And once I take this apart, I'll show you how exactly it works and how to clean and service them. But that's how it works there. And that's one of the things we're going to have to service. See there's the CRT. Pretty nice scope actually, but we have to see what's wrong with it, of course, because it did say it does not work. And I do believe that likely probably does not work because most of these don't. Because I know I had one. But there you go. Beautiful piece of equipment. So that'll be the future repair videos coming up. It's probably going to be several parts because this is going to be extensive servicing. I'm pretty sure it's going to have multiple problems. So we're going to go ahead and attempt to power this thing up and kind of verify the fault with it. The guy did say that he couldn't get a trace, beam vine, nothing worked, so pretty sure this thing's broken. They normally are. I already have a suspicion I know what the problem is, but I'm not gonna, spoil it. We're actually gonna go do a troubleshooting on it instead. But let's go and fire it up. Hopefully we won't get magic smoke, but if we do, at least I got the camera to capture it. So let's power it on. And yeah, we got light and stuff, so that's good. Let's just see the scale. I want to see how bright that is. Oh yeah, that's a CRT. Might actually have good. This thing might not have as many hours as I think it does, so that's a good thing there. Let me look at the anode over here. Yeah, there's some dust buildup, but not a lot of it. I'll have to look back there, but normally that's a telltale sign. You can usually tell the hours on it just by how much dust buildup is on there. Shockingly, a strange way of doing it, but yeah, high voltage attracts dust. And let's just see if we get a beam fine. And yep, nope, it's dead. Make sure the position's there. Try again, and nothing. So turn it off because I believe one of the voltage rails on the low voltage supply is shorted. That's normally what causes it. And I suspect it's probably gonna be the 15 volt rail, which is probably the first thing I'm going to look at. But I do want to get the full service manual printed, and that's going to be a lot of paper pretty much. But I like to do that because I like to have the schematic in front of me versus looking at a screen. It's much easier if I gotta have to circle things and stuff like that, areas of interest and stuff. I can actually find it and concentrate on that area and stuff versus looking at a screen. So that's probably what I'm going to do, and this is going to be upcoming video. I guess the first part of it's going to be troubleshooting and testing the power supply and testing the voltage rails and so forth. And we'll do it probably powered off, obviously. We'll just do a resistance check to see which rails shorted. And then from there, we'll follow the service manual, and hopefully we'll find the shorted component. And then go from there. Of course, I'm pretty sure this thing's going to have multiple issues because they typically do, because I have serviced several of these in the past. But we'll go through them. We'll see it. And one of the things I definitely know I'm going to have to service is the attenuator. Pretty much, because those are problematic on these. I know on mine it was problematic, and I'm pretty sure on this one it's going to be no difference. The other thing I'm kind of curious to see is there's a lot of hours on the CRT. I was saying the nanode looks pretty clean, so this might not have tons of hours. And being the fact that illumination scale was bright, because normally they have a lot of hours, they burn out and stuff like that after a while. And that thing was pretty bright. Matter of fact, let me get back to you. I'm going to remove this blast shield, which is also blast and also filter too, but it also keeps it the CRT decides to implode, it keeps the glass from coming out and stuff too as well. I'm going to remove that. I'm going to take a look at that illumination scale and see if it's melted, because over time they have a lot of hours. The heat builds up and it distorts the plastic and stuff like that. that will kind of give me an idea if this thing has tons of hours or not. So I went ahead and pulled the incandescent bulbs out just to see the, because you can kind of tell the hours that's on. So not everyone uses the illumination scale, but if you're looking at high frequency in a dark room, you're probably gonna be using it. So doesn't look like it has very many hours at all on this thing. And I mean, the CRT is even clean stuff. And like I said, high voltage attracts dust. And normally it'll be dust and film buildup on it, but there's none on this. And also the fact that the anode's pretty clean and stuff like that tells me this thing's probably low hour, and there's no wear marks and stuff on the front panel that you usually see on these things. So this is going to be a good one to restore, assuming that the CRT itself survived the trip and it didn't gas out and stuff like that, but I don't think it did. But let's go ahead and take a quick look at the power supply. So one of the first steps you want to do when troubleshooting any piece of unknown gear is always check the power supply sections pretty much. And first thing I typically do even before that is I'll go ahead and check for any burnt or charred components and stuff like that, because that will usually give you a visual clue to the area that you need to focus on pretty much. And that's one of the first steps that I do, and I usually also give it the sniff test too to see if there's any burnt electronics smell, anything that smells like it was burning. And then I'll look for charred and burnt components and so forth. And unfortunately, I didn't find any on here, so I mean, I guess that's a good thing, but I did find a clue, and it's with this F1419 fuse. I'm already 99% certain what components actually short it, but I'm not going to tell you. The next step you want to do in troubleshooting is, if nothing's, obviously burnt or charred or anything like that, is of course to go on each of the rails and check to see if there's a dead short on any of the rails and stuff like that too, because then you can focus on that rail. And sometimes it's not the power supply that's the issue, it could be actually the load that's the issue, and then you can go further down if you have to and figure out where the short is and stuff like that. So those are usually always the things that I troubleshoot. If I don't find no short on the rail, then I'll go ahead and power on the power supply, of course. In this case here, I obviously powered on the scope right at the beginning. That was because the seller already did that, so I figure what's burnt's already probably burnt because he went ahead and tested it. So that's why I took the chance and of course powered it up and stuff like that to verify the fault. But normally I wouldn't do that. Normally I would actually go ahead and check to see if any of the rails are short at first before I attempt to power it on, because you can cause more damage. And then once I verify that there's no short and that it's safe to power on, then I'll power it on and I'll see what voltage rail's missing voltage, of course. And then from there, if a rail's missing voltage and stuff, I'll figure out why it's missing the voltage, if it's on the power supply side or is something loading it down. But that's usually the first steps that I take. Now, like I said, this F1419 that goes to the HV power supply is a very good clue what the issue is, and I'm 99.9% certain I know exactly what component actually went short, and an exact component that's actually shorted, because I have actually fixed many of these over the years, and it's a common issue, and about 20 of them had the same exact issue. But I'm not going to tell you. The reason why I'm not going to tell you is because we're going to do it the proper way. We're actually going to download the service manual, and the service manual thankfully has full schematics. And then we're going to print out the areas of interest once I pick up some more printer paper, because I'm going to need a lot of it. And then also too, once I get the camera set up too, because I actually this time around going to do it different. Instead of just telling you what the fault is, we're actually going to troubleshoot it step by step, and we're going to go down the line until we get to the component of interest and stuff like that. And then we're going to narrow it down, so that way if you have to troubleshoot a piece of test equipment, you'll know how to troubleshoot it and stuff like that. And thankfully with this older test equipment, they have full schematics and detailed service manuals, so it takes you step by step to lead you to the area of interest and stuff like that, to be able to effectively troubleshoot. And that's why I love working on older gear like this, because there's full-blown schematics and a full service manual. Unfortunately, with newer equipment nowadays, they give you block diagrams, and pretty much you'll be lucky to even get a block diagram. And when they do give you a block diagram, it's pretty much, okay, if this is doing this and this is doing this, it'll give you steps to take. Then it's going to lead you to this board, and then it's just going to tell you replace whole entire board, pretty much. That's how the service manuals are nowadays compared to the older service manuals, where it takes you step by step and tells you disconnect this, check the voltage on this, check to see if there's a short on this, and then if there is, then go to this, and it takes you step by step pretty much until you find where the problem is and where the fault is and so forth. That's why I love working on this older equipment, because it's a lot easier to service when you have full manual and full schematics, of course. Now, I am going to go ahead and fully restore this properly, because this got a lot of tantalum capacitors. We're also going to fully also service the power supply, because if there's ripple in that power supply, it will cause the tantalum capacitors to fail short. And when they fail catastrophically, where they end up, heating up, they end up catching fire, and then leaving a nasty toxic smell that you don't want in your room for days and stuff like that too. So we're actually going to go ahead and replace those. But before I do that too, we're also going to check the ripple on the power supply, because there's two things that kill a tantalum capacitor, and that is excessive ripple and heat. Two enemies of those capacitors, and that's what causes them to short. They're actually pretty reliable as long as those two things don't take place, but if one of those two things take place, they will go up in smoke and typically dead short and catch fire. So we're going to actually do a proper service on those things and pretty much check everything out. So that way, if I do decide, which I'm likely going to keep the scope because it's low hours, and I have a soft spot for this scope, because this scope was literally the first one I learned on, but it's also a great analog oscilloscope, probably one of the best that Tektronix made. And being the fact that this is a low hour scope, because every indication gives me that this thing is pretty much low hours, this is definitely going to be a keeper. So that's the other thing too. I do got to find the 2 feet that are missing back with the screws and stuff like that, because I do want to get this thing complete too as well. And we're going to service it properly so I can make it reliable, and I can trust when I power it on, it's not going to let the magic smoke out. So watch out for part 2. Probably going to be a little while, because I do got to get the camera and the GoPro set up, because I'm not going to do like parts where I just tell you where the fault is and that's it. We're actually going to do it step by step, so that way you can be able to troubleshoot yours on your own, because it could have a different fault. And then you'll have a good idea how to actually locate and find that fault, instead of relying on Google or whatever to find the fault and stuff like that. And you'll be able to troubleshoot it properly without help from Google or YouTube and stuff. So there you go, and this concludes part 1 of the video. So I decided I'm going to go ahead and give you this one, because it's such a common issue. I might as well, and it may help a few people out. Typically what will happen is, before this capacitor fails, because that's actually what failed, it went ahead and went dead short. I got it out of circuit right now, and you can see there's still a short, and that's because it took the driver out. Now I did test, of course, to make sure the leads itself wasn't touching the ground. It is definitely that transistor, so I'll have to find a replacement for that. But you can see the short's now gone. And hopefully that will get the horizontal working. There is a couple tantalum capacitors that also like to fail in this high voltage section too as well that I do. And I am going to go ahead and replace them as well. But there you go. Hopefully once we fix that, we'll get the horizontal working. And hopefully we'll get a trace on the screen that there's no other issues. But I'm pretty sure I'm going to find a few, because these 465s are known for it, unfortunately. And yes, I am going to do the full restoration. So this is going to be a several part video. It's not going to just be part 1. There's actually probably going to be a lot of parts to it, because I'm going to have to go through check ripple, check the voltages and everything, and also replace pretty much a lot of tantalum capacitors and so forth after I get done rebuilding the power supply pretty much. And then we're also going to have to deal with the attenuator and stuff like that too as well and stuff. So this is going to be pretty much a project, but I figure I'll go ahead and give you this one. And I kind of suspected it already, right? Because there was another clue which I kind of missed on the early parts of the video. One of the screws were missing on this high voltage shield. So it tells me that someone was inside it already and probably knew what the problem is. But obviously the driver itself was the problem and they decided not to mess with it. Or they couldn't figure it out and sold it on eBay as is pretty much.